Chapter 13, number 17. The position of a mass on a spring is given by the following equation. X equals 3.8 centimeters times the cosine of 2 pi t over 0.88 seconds. A, what is the period t of this motion? B, where is the mass at a time of 0.55 seconds? And show the time is at the same place 1 t later. So let's rewrite our equation, and we're going to say that X is 3.8 centimeters times the cosine of 2 pi, the time over 0.88 seconds. And I did some coloring there because I want to model it against what we already have. We're going to have that our general equation for simple harmonic motion, again, the case where you pull something back and then release it at t equals 0 from rest, then your equation will read x equals a cosine 2 pi t over capital T. And so we can do formal equivalences here to identify that the amplitude must be 3.8 centimeters and the period must be 0.88 seconds. So that's part A. For part B, we want to know where it is. We want to know where, which means we're looking for a value of x. In fact, we're looking for the value of x. So part B says, what is x at 0.55 seconds? And we can just throw into the equation they gave us, which was an equation for x at any time. So it's going to be 3.8 centimeters times the cosine of 2 pi 0.55 seconds over 0.88 seconds. And luckily, everything is all on one side, right? We just want x, so we can just throw that into our calculator and find minus 2.687 centimeters, which, because we have only 2 sig figs, means that our answer is really minus 2.7 centimeters. But what if you went through all of this correctly, and then you ended up getting, your calculator said that it's 3.79 centimeters? Well, that comes from not being in radian mode, because this equation requires the argument to be in radians. So if you were still in degree mode from some other problem, you would get this other wildly inappropriate answer. Sadly, there's no easy way to tell offhand on that, except that it's very close to the amplitude, even though we're about halfway through the period. So maybe that will clue it in. All right, and then part C says, show that the mass is the same location at 0.55 plus t. But really, this is nothing more or less than plugging in the 5 seconds plus the 0.88 seconds, that is the period, and throwing that into the calculator, we quickly get minus 2.687, which is exactly the same answer, actually, which is nice. And that's not too surprising, because that's what the period means. If we move forward by that much time, we get exactly the same place. Notice that even if you were in degree mode, you would get the correct repetition, even though you wouldn't get the correct answer, which is kind of strange.